Welcome to Pomodoro Joe for Friday, January 27th, 2023. Today we're looking at LeetCode problem 472, concatenated words. This is a hard problem. And the problem statement says, given an array of strings called words without duplicates, return all the concatenated words in the given list of words. A concatenated word is defined as a string that is comprised entirely of at least two shorter words in the given array. And then there's some examples. All right, so without further ado, we'll set 25 minutes on the Pomodoro timer. Okay, so you might be tempted to sort these by length. That might help, but I think what I'm going to do is actually just throw them all into a set, and that way it's easy to check if something exists. So let's just have a set of words, and we'll just say set words. Cool. All right, the other thing we're going to need is some result, and we'll start it out as an empty list, and then we will return our result at the end. And it would help if I spelled things properly. Okay, so we have a set of words, and we have some result, and we'll need to figure out if it's a concatenated word. So we'll have some function called isConcatenated word, and it will take the word, and it will return a Boolean, and we'll come back to this one. I don't really know what it's going to do just yet. And then down here, we'll just say for word in our word list, for word in our words, if is concatenated word, passing in our word, then if it is, we'll add it to our output result. Append word. Right. Word. Okay, so now we have to get down to the tough stuff. How do we figure out if this is a concatenated word? Well, let's see. If the word is already in our set of words, that's not going to work out. Let's see. If word is in our set of words, what does that tell us? Well, that just tells us that this word is in the set, but it doesn't tell us if it's concatenated or not. Now, the problem that we run into is if this is our end case, our base case for a recursion, then the word will be a standalone word in our set of words. So we kind of need to know whether or not this is our top level word, or if this is one of our recursive words. So let's have some like is recurse, and we'll set the default to true so that we know if we've gotten into this. Okay, so let's see. If the word is in the set of words and this is a recurse, then we can return true, because we've already come from some top level word. This is one of the base words, and we can append it to the end, so we return true. Cool. That's one base case taken care of. What other base cases are there? That might actually be the only base case. I guess the other base case is if this word is empty. But I think we're going to handle that in our traversal next. So next thing we're going to do is split this into left and right. So basically we're going to split the word into a left and right. We're going to take the left word. If it's in the list, then we'll recurse on the right half. So we'll say left is equal to, well, we need some index here. So actually what we'll do is say for some index, this is our split index, I'll call it that. For our split index in range from, let's see, length of word. Might actually be easier to just start this. Yeah, I'm going to do that. We'll just start split index as 0, and we'll say while it's less than the length of word. That's way easier. So we're going to split our word into two pieces. We'll start at 0, and we'll say while our split index is less than the length of our word, then we can split our word into left and right. So the left is going to be our word up to our split index. Now we've already set it to 0 to start with, so we might want to set this to, we increment here, so our split index plus equals 1. So we'll increment our index before we do the split. This way we can start at 0 and we don't have to worry about empty words. If we started this at 1 and the word is empty, actually that might work too. Let's try that. Let's just say we'll start it at 1. Okay, so we can start it at 1. We're going to split left, and then our right will be equal to our word from our split index to the end. All right, and then we will have to increment our split index. But before we increment our split index, let's just check if the left is in our set of words. So we've split the string into 2 pieces. The left piece is one of the words in our concatenated list. So let's check the right. So if the left is in the words and the is concatenated word, let's just grab this for our right, and we have to pass in true for a recurse, which is defaulted to. That's great. So, and if the right is a concatenated word, then we're done. We can just return true, because both the left and the right are concatenated, or are words that can be found in our word set of words. Okay, and if we get to the end and none of those turned out to be concatenated, then we have to return false. Okay, one last thing I need to do. I think that's it for this recursive piece. One last thing I need to do here is pass in the is recurse of false to begin with, because this is a top level word. And let's give that a shot. Okay, I messed something up because I can't type. Try that one more time. Okay, that seems to pass. Let's submit it, see how poorly we do. Not great. 20%, so it beats 20% for runtime, 40%, 47% for memory, so that's not too bad. A couple things we could do here. This is only taking in one word, which is a string, and a Boolean, so we can cache the result of this. So let's actually try that out here. So from functools, we can import cache. And down here, we can just use the cache decorator. So that will cache the result. Anytime we have the same input, it will just return the cached output, as long as it's computed it once before. Let's see if that saves us anything. That actually saves us a lot. Now we're up to 43% for runtime, 34% for memory. I'm sure there are other things we could probably do in here. Let's see. I mean, the left and right, we don't actually need these. We're just doing this split index. So we could actually just grab this whole thing here, and instead of saying if left is in, we can say that's the left and this is the right. So we can do that. It was just clearer to use left and right, but let's pull those out. And that makes it a little bit easier to read. Well, it makes it a little bit shorter to read, I guess. Maybe not easier. One last go. And we made it to 85% for runtime, 34% for memory. That's not bad. Couple tweaks to our algorithm, we were able to get it from a 20% up to an 85%. Yeah, that's not bad at all. Okay, with that, I think I will leave it here. This was a hard problem, but if you break it down into sub-problems, it's not too tricky. I would totally recommend you check this one out on your own. Check out the other solutions. There are different ways of doing this. You can use backtracking. You can use top-level recursion. I'm sure there are other ways, probably graph traversals, tries, or trees. I don't know how you pronounce it. There are multiple ways to solve this one. Clearly, we have a decent solution, but there's room for improvement. We only made it to 86%. Somebody's got to have a 90% solution. Okay, hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.